Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. We are from group 2. So today we will discuss about fault analysis. So we will proceed to question 1.
Right.
Question 1. Okay.
Okay, so in the question number 1, the first criteria that we need to see is axial and radial. So
Yes,
what you
lens
see in
spectrum.
the question?
You can see lens spectrum at the radial direction
Radial.
is more higher than axial, right?
Yes.
Yeah, correct.
I
So
agree.
obvious.
So
The first criteria,
we know that the first criteria
radial is more higher than axial.
first is radial higher than axial, right?
Yep, correct.
Yes.
Okay, so the second one we look at the dominant. 1x or 2x dominant, am I right?
It's not
See,
dominant.
Then
see, what lens spectrum are there? So you can see 1 and 2, right? 1x and 2x.
Yeah,
1, 2, 3. I think 1
2,
1x
3.
and 2x.
1
1x,
and 2x, yes.
Yes.
1x and 2x. We have here 1x and 2x line spectrum.
Yes.
And then
Okay.
I think 2x is
The
bigger than
criteria is we need to check the which one is greater.
yes.
At position 1 and 4, the 2x is bigger than 1x.
Yes, for
Yes.
okay.
Position 1 and 4.
We know that 2x is bigger than 1x, right?
Yeah.
Okay. So next we have look at the phase difference.
Yeah, phase difference.
Phase difference. Okay.
The first one is 2v minus 3.
Minus 3v,
Yeah.
2v minus 3v.
which is 210 minus 50.
Yeah, so the
Fourth one.
fourth
Phase
is 2v minus 3v.
3v.
So 2v is 210 and
Minus
minus 50. We get 160. Okay.
Wait, before that, we can see that for criteria number 2, there is 1 and 2 x line pattern, right? So it must it may be for imbalance, looseness, or parallel misalignment, if I'm not mistaken. Right.
There are 3 possibilities for the
Yes.
So we continue for phase difference, right?
Yeah.
Yes, to determine which one is the fault.
Okay. So
the next one is 2h minus 3h.
2h minus 3h.
Yeah.
2h minus 3h. Okay, boss. So 3h, 2h, we know is 190. Minus
35.
Minus 335, we get 155.
155.
155 degree.
Yeah.
And then
the next
we
one,
find the 2a,
minus 3a,
2a and minus 3a. 2a minus 2a, 2a minus 3a. Which is 205 minus 45. So you got 160.
Yep.
yes.
So
Okay,
these 3 phase
These three
difference
phase difference.
fulfill the criteria 180 plus minus
Yes.
plus minus 30
180
degree.
plus minus 30
Okay, the
degree.
fault is parallel misalignment, right?
So
Yeah.
we have this
This criteria, all the criteria fulfill the parallel misalignment.
parallel misalignment.
Correct? I agree.
Yes.
Yeah.
So
Parallel
that's all
misalignment.
for question 1.
Yeah.
So we jump to
I think
the
so.
question number 2.
Alright, let's go.
Sorry for my
Okay.
words.
It's okay.
Feel nice.
So we proceed for question 2.
Yes. Let's go question number 2.
So the first thing we have here is we can see that the
Position and number 2.
We look at position 1 first. Position 1
Yeah,
first.
one first.
Radial is larger than
Axial. Yep, radial
Yes.
is bigger than axial.
True.
so for question number
Position
2, question number 2, we have axial, right?
Position 1. Yeah, at position 1.
At position 1.
Okay, at position 1.
Yep.
Position 1. Position 1, okay. We have here is axial radial bigger than
Radial.
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 Radial is bigger than axial.
sorry. So radial bigger than axial, right?
Yep.
Yep.
So the second
Okay.
The second criteria,
criteria is
The one.
1x, 2x, 3x.
yeah, 1x, 2x, and 3x.
We have 1x, 2x, 3x. Okay, so this first. So the second we have a 1x, 2x, and 3x.
Yeah.
Yeah.
So the third criteria is we choose which is one the biggest.
1 and 2x is bigger than 3x.
Yes, that's right.
Yes.
1 and
So
2x bigger
1x
than
and
2x.
2x is bigger than 3x.
3x, yeah.
In radial
In radial direction.
Yep.
Okay.
So it may be looseness, right?
Yes.
It can be looseness.
Looseness type B.
What type of looseness?
Yes.
So
looseness.
1x and 2x
Is bigger than
3x
in radial direction.
in radial direction. Okay.
Yes.
Radial direction. So we can know that this is looseness type B.
Yeah, pedestal.
Yeah, pedestal. Thank you.
So that's it, right? For position
So
1.
Looseness type B.
Looseness.
So this is for motor at position 1.
I see. Okay.
for is looseness type B. Allah Akbar. Okay, same time. Type B. Okay, this which is pedestal, right?
Yeah, pedestal.
Pedestal. So this for
That is for the position at
motor
position
position.
1. You can
So
there is also for at 2 and 3, position 2 and 3.
So position
What
2 and 3. Aiman?
Okay,
What do you think?
What do you think, Aiman?
Position number 3,
2 and 3.
I
Position 2
think
2
and
and
3.
3 we have coupling.
yes.
Yeah, coupling at 2 and 3.
Coupling. So we look at 1, 2, and 3. We have axial bigger than radial.
Yeah.
Yes.
Yeah. Right.
Alright, so for
3.
position 2 and 3, we know that the first criteria is axial bigger than radial.
Yes, correct.
Alright, so
For the
the second one. The second one.
Second one, there's I think 1x, 2x, 3x, and 4x. Right?
Yes,
Yes.
correct. There is 4.
1x, 2x, 3x, and 4x. And I think 1x is bigger than 2x, right?
Yeah, 1x is bigger than 2x.
Yes. So
For the third criteria.
for the second criteria is we have 1x, 2x, 3x, and 4x.
Yes.
4x.
And then for third is 1x is bigger than 2x. Okay. And the fourth criteria, what do you think, Aiman? We have to find the phase difference.
So we 2b minus 3b, yeah?
Yes, good job, man. Good job. We find the phase difference. So the fourth is
different.
So
2v minus 3v, which is 25.
25 minus 18.
Minus 18, right?
Yeah.
So we got 7
7 degree.
7
And,
degree.
and then we find for 2H minus
The next one
3H
is, yeah,
H
the
minus
2H.
3H.
and 2A minus 3A.
3A.
Yeah.
Yes.
All right, so we proceed for the solution,
For 2H and
which is
3H minus 3H is 62 minus 59.
all right. Thank you, husband.
Yeah.
62 minus
Let's say 3
59,
degree.
and then we got 3 degree.
Yes.
And the last one is 2A minus 3A, which is 21
218.
208
Minus 23.
23, and we got 195.
195. Yeah.
All right.
For the first and second, the phase difference is fulfill the 0 plus minus 30 degree for the first two.
Yes.
For the
Yes.
first two.
Oh, for the first two.
Yeah,
For the first
0
two.
plus
Okay, sorry.
minus 30 degree.
So for the first two is 0 plus minus 30, right?
Yeah.
Yes.
Minus 30 degree. Okay. And
For the third one is
the one is 180
yeah.
plus minus 30. Yeah. Right.
So we can determine what
So we
what
conclude
is
that
right.
the type of unbalance is angular misalignment.
Good
Correct?
job, Aiman. Good job. Angular
Yeah.
misalignment. Angular misalignment we got here. Angular misalignment. Misalignment. Sorry for
at position 1
alignment.
looseness type B, and then position 2 and 3 angular misalignment.
Yes. So
That's all for question 2, I think.
yes, that's all for question 2. And then we proceed for question 3.
3.
Aiman, what you got here?
Let me check the question. So in the question, I think we look at I think it's a bit hard.
I think from the this
radial is almost equal
almost
to AZ.
equal to AZ, right? Right. So
Yes,
the
because
first
it's quite same, right?
the first criteria radial slightly same to AZ, right?
Yeah.
So for question number 3, for the first is radius
equal to axial.
Equal to axial.
Yeah.
So next is for the dominant.
There are two spectrum,
Yeah.
one X to X.
One X is dominant.
One is
dominant. Yeah.
First,
yes, one X
we
dominant.
list out first what less spectrum it is, one X and 2X. So there are one X and 2X.
One X.
One X is dominant compared to 2X.
2X. Okay.
That one is the
Like this.
criteria, right? Dominant one X.
Yeah.
So dominant 1X, right?
Compared to 2X.
Dominant 1X. So the third is if we must find the phase difference.
We look at region 3 and 4.
Yes, region 3 and 4. Okay.
So
Region
3A
4.
minus
3A minus what, man?
3 and 4.
4A.
Okay, thank you. So 3A
119
minus 4A, just 119. What one?
Minus 98.
minus 98.
Minus 98. Good job, guys. Good job.
We got
We got
21.
21. So boy. So we have here the what you call it?
The properties state that
0 plus minus 30.
Yeah, 0 plus minus 30 degree.
30 degree.
So based
fulfill
on the
the
criteria, it is
So we can determine this is overhang.
overhang.
Based on all of the criteria that we list out.
Overhang. All right, for the last question.
Question
number 4.
Number 4.
Number 4.
So we have here, we have to
Add
check.
position
Position number
one.
one.
One and
Number one
two,
and two
motor.
is same, which is at motor position.
Radial is bigger than axial, right?
Yeah,
Yes.
it's obviously that radial
Obviously,
is
obviously.
obvious than axial.
And the criteria number 2, we can see here was 1x is dominant.
True.
Yeah, dominant one
Right.
X.
There are
True,
two
man.
term 1x and 2x, and the dominant is 1x.
For motor, okay lah. For motor,
One and position one.
1 and 2. All we got here is the first is radial.
Bigger than axial.
Bigger than axial. Right.
Yes.
And we know that 1x is dominant.
Yes, true.
Yes,
But
true.
there are two 1x and 2x.
Dominant
There are
1x.
two line spectrum 1x and 2x, and the dominant is 1x.
Oh,
So
okay.
it may be unbalanced or looseness.
Yes,
It can be two possibilities.
Yes.
Two possibilities. Unbalanced and looseness.
Looseness, yes.
Oh.
Either one.
So we look at the question.
To determine which one it is, so we need to calculate the phase
Phase
difference
difference.
Phase difference.
between 1 and 2.
1 and 2. So 1v minus 1h, 2v minus 2h.
Yeah, for unbalanced.
Alright.
Different for unbalanced.
And then okay, 1v. The number 3 is 1v minus 1h equal to 115
5 minus 8.
We got 107.
107.
107.
And then for 2v
Position 2
and
2 minus 2h.
2h 285
Minus
190.
190.
So we get 95.
We got
95 degree.
Anas. It's 190.
Oh,
285 minus 190.
Oh, not 105. Sorry,
Yeah,
my bad. 190. Okay, thank you, husband. So we got here is 95.
Degree.
So these two phase different fulfill the.
So it satisfies the criteria number 3 for unbalanced, right? We know that it is unbalanced. So next we need to know which type unbalanced it is. Need to calculate for the
1h minus 2h.
Yes.
Yeah, 1h minus 2h and
1v minus 2v for the last criterion. So the fourth is 1h minus 2h equal to 285 minus 115, and we got here is 170. And then 1v minus 2v, we got here is 190, and minus a, we got here 182.
182, correct.
So this degree between 180 plus minus 30.
Minus 30 degree.
So we know that
it is couple unbalanced.
Oh.
This type is couple ambulance, fulfill the couple ambulance.
couple line. Couple ambulance, eh?
Yes,
Couple
for
ambulance,
position
yeah.
1 and 2.
Couple right. Couple
1 and
ambulance.
2, for position at 1 and 2, the what is couple ambulance.
Okay. So we move for the position
Pump.
3 and 4. Yes,
Yeah,
pump.
which is pump.
Pump.
3 and 4.
So what do you think, Ayman?
Asia is larger than Asia.
Okay, axial bigger than radial, and we have here 1x and 2x.
1 is
What is the dominant, Akmal?
Dominant is it is obvious 1x, right?
Right.
1x the
I'm just
dominant.
test you, bro.
Okay.
Okay, so for the pump. So pump at position 3 and 4.
3 and 4. Yes.
So the first is axial
Bigger than radial.
bigger than radial. And the third criterion, we have 1x and 2x.
Second criteria, and the third criteria.
And the third is dominant 1x.
Yes.
So the
So
possibility
it may be
possibility.
two
Yeah.
fault.
Two.
two possibilities.
Ben shaft
Yes.
Ben shaft and
Ben shaft
angular
and angular misalignment.
Yes,
misalignment.
angular misalignment. Yes.
Yes.
Two possibilities can be.
Possibilities angular misalignment and Ben shaft. So when we have to confirm it, we have to find the phase different.
Yes, to know which one, which fault it is.
Phase different. For the part we have like 3A minus 4A, right?
Right.
So for the first difference is number 4. 4 is 3A minus 4A. We got here is 118. 218 minus 42.
Minus 42.
You got here 176.
176 degree.
So it range between 100,
So it is
180
between 180 plus minus 30.
plus minus
30 degree.
plus minus 30 degree. Okay.
So this fulfill the Ben shaft criteria.
Oh, so we got here is Ben shaft.
Oh, so it is Ben shaft. Okay.
This is Ben shaft, I think. No,
Ben
it's
shaft.
Ben shaft.
Ben shaft, right?
Yeah.
Right.
So there are two faults for this system.
So
So I think
okay.
that's all from us. I
It's
think.
all
So
from
that's
us.
that's all right.
Yes.
Anything
All,
else?
all
Okay.
correct. Alhamdulillah.
Okay, thank you all for
Okay, for the
joining
discussion.
Yeah.
Maybe
Thank
see
you.
you
Thank
again
you.
next time. And thank you.
Right.
Thank
Thanks for
you.
the cooperation,
Thank
guys.
you.
Salam. Bye.